All right, this is going to be notes 4.11. We're going to do quadratic inequalities. All right, so a quadratic inequality in one variable are inequalities that can be written in one of the following forms. Okay, so pay attention here that all of these are going to be equal or less than, greater than, less than or equal to, greater than or equal to 0, where A, B, and C are going to be real numbers. So, the procedure for doing this is we're going to move all the terms to one side. So there should be a 0 on the other side. Then we're going to simplify and factor the quadratic expression. We're going to find the zeros of the corresponding quadratic expression, and then we're going to use the zeros to divide the number line into regions. We're going to test each region using the inequality. So for our example is we're going to start with this. X squared is greater than x plus 2. So step 1, we're going to move everything to one side. So I'm going to get x squared minus x minus 2 is greater than 0. Next, we're going to factor and find the zeros. So we're looking at x squared minus x minus 2 equals 0. So we're asking ourselves what multiplies to give me negative 2, adds to give me a negative 1. So hopefully in your heads, you guys are going, that's going to be negative 2 and a positive 1. So when this guy factors, we're going to get x minus 2 and a x plus 1. Okay, and then to solve this, we set each one equal to 0. So x minus 2 equals 0. So x will equal 2. X plus 1 equals 0, so x equals negative 1. All right, so now we're going to divide our number line into these regions. This like middle section you guys are able to skip, but I'm just like listing out, or I'm showing you guys what's going to happen. So at negative 1, we're just going to draw like a bar here at negative 1, and then we're going to draw one at 2. Okay, so we have 3 different regions. We have region 1, region 2, and region 3. All right, so then we're going to go ahead and test each region. So in other words, when I say test each region, you're just going to pick a number that falls within those, and then we're going to see, is it true for that area or is it false? So for our first test region in region 1, let's just pick x equals negative 2. So the inequality, so we're plugging it into the inequality. So we're going to get negative 2 squared is 4. Negative x will give me a plus 2. And then we'll get a minus 2 is greater than 0. Is this true or false? So 4 is greater than 0. This is true. So region 1 is true. So that means the answers will fall here. Okay, you test something in your region 2. So 0 is always easy. X equals 0. So that's going to give me 0 squared is 0 minus 2 is greater than 0. So negative 2 is greater than 0, which is false. So it does not work in region 2. And then we have region 3. So let's pick 3. X equals 3. So then we're going to get 9 minus 3 minus 2 is greater than 0. So we get 4 is greater than 0, which is also true. So region 3 is also true. So when we graph this, and you guys hopefully should remember this from doing inequalities at the very beginning of the school year. So first off, is it an open circle or a closed circle? Since this is greater than and not equal to, these are open circles. So at negative 1, we have a nice big open circle. At 2, we have an open circle. And then these arrows are going to be going away from each other because it is true in region 1 and region 3. So that's the direction those are going to go. And hopefully you guys just remember, greater than goes away from each other, less than goes towards each other. So we write our solution. I'm going to show you guys how to write it in inequality form and in interval form. So inequality form, I would say x is less than -1 or x is greater than 2. Okay, the other way in interval form would go -infinity to -1 with a parenthesis because -1 is not included, it's an open circle, union with or and 2 to infinity. Again, the 2 having a parenthesis because it is not included. All right, so let's go ahead to the next page and try these out. So our first one is 16x squared is less than 64. So again, step 1 is to move everything to one side. So we're going to get 16x squared minus 64 is less than 0. Step 2, factor this, always checking for a greatest common factor. So we're going to get 16x squared minus 4 is less than 0. Okay, factor this. This is difference of two perfect squares. So we're going to get x plus 2 and x minus 2 is less than 0. All right, solve it. The 16 you just ignore. There's no x. So then we're going to get x plus 2 equals 0. X minus 2 equals 0, so we're going to get x equals -2 and x equals +2. Okay, this is less than, so this is going to be open circles because it's not equal to. So I go to -2, put a big open circle. I go to 2, put a nice big open circle. Okay, and then we can just test our regions. Hopefully you guys know it's less than, it's going to go in between, but let's make sure that that is true. So you test each region. I'm going to start by testing 0. So if I were to plug this in, I would get 0 squared is 0, so 16 times 0 is 0. So 0 minus 64 is -64 is less than 0. This is true. Okay, so remember, then these will be false because it's either they're, wow, can't spell. So either they are going away from each other or they're going towards each other. So in this case, since it's less than, these will be in between. Those will be my solutions. So we'll go ahead and write our inequalities. I'll do inequality notation and I will do interval notation. So remember, inequality would go -2 is less than x, which is less than +2. That's the in between. So this is inequality notation. All right, if we did interval notation, we would go from -2 to 2. Both of those in parentheses because those are both open circles. This is called interval notation. All right, let's go look at example number 3. So again, step 1, move it all to one side. So we're going to get x squared plus 10x plus 16 is greater than or equal to 0. Step 2, factor and solve this. So I'm looking for what multiplies to give me 16, adds to give me 10. So hopefully you guys are all thinking 8 and 2, positive 8, positive 2. So when this factors, we're going to get x plus 8 and a x plus 2 is greater than or equal to 0. Okay, solve them. So this first one, x plus 8 equals 0, so x equals -8. Second one, x plus 2 equals 0, so x equals -2. Okay, this is going to be closed dot because this is greater than or equal to each other. So at -8, we're going to have a nice closed dot. And again, these should be obviously open, obviously closed. -2, nice closed dot. Okay, test the regions. You should know, though, this is greater than, so they should be going away from each other. But let's test 0. I always like 0. It's just the easiest to test. So 0 squared is 0. 10 times 0 is 0. 16 is greater than 0. That is true. So this is true. This middle piece will be false. And this down here would be true. They should be going away from each other. So should have it going this direction and this direction. All right, let's go ahead and write our solutions. We'll write them in both forms again. So the first piece would say x is less than or equal to -8, or x is greater than or equal to -2. Interval notation, I would go from -infinity to -8. Bracket because it's a closed dot. Union, bracket because it's a closed dot. -2 to infinity. All right, and that's how you do those two. All right, this next section, I'm going to skip this. I'm changing these notes to better align with your guys' ALEKS assignments, so just ignore this page. And on this page, I want you guys to update this page so it looks like mine. So we're going to talk about two-variable quadratic inequalities. We have kind of talked about these when we did other inequalities. We did have a few quadratics thrown in there. So this is what I want to talk about and discuss. So when I'm saying two variable, so like these ones were one variable because there's only an x. They equal 0 or they're less than 0. Two variable means that there's an x and a y. So this is when we shade regions. Okay, so go ahead, call this page two variable quadratic inequalities. And we will go ahead and write these problems down. Okay, so for this type of problem, you want to get y by itself on one side of the inequality. So obviously on this first one, we're going to go ahead and add 2. Add 2. So we're going to get y is less than x squared, and then that's going to give me -5. All right, next step is we're going to go ahead and graph this. So just talking about this graph, we have a -5 on the outside of the equation. So this is going to shift it down 5. Nothing else is changing. There's no stretch or shrink. There's no right or left. It's just going down 5. No reflections, nothing. So I'm going to go ahead, graph this down 5. So I'm going to go 1, 2, 3, 4, 5. This would be the vertex of my parabola. Okay, there's no stretch or shrink, so we can use the whole 1, 3, 5. So over 1, up 1, and it's reflected. Over 1, up 3. Over 1, up 3. Over 1, up 5. And it's a reflected point. Okay, so that's what that parabola looks like. Okay, so the next thing we need to ask ourselves is this a dashed line or a solid line? And since it is just less than and not equal to, this is going to be dashed. And since y is less than it, we're going to shade below. All right, so we're going to connect this parabola with a dashed line. Okay, arrows on both ends, it does continue. And then we're going to shade below the parabola. So that's all of this. Okay, and that's how you would do that quadratic inequality. So anything in this shaded or this highlighted region, any of those points would be a solution to this inequality. All right, let's go ahead and try this next one. This next one's going to be in standard form. So again, step 1, we're going to go ahead and get this to equal, or just to have y by itself on the one side. So we're going to get y is greater than or equal to 2x squared plus 12x plus 17. I'm going to go ahead and change this to vertex form just because vertex form to me is the easiest way to graph. I'm not the biggest fan of T-charts, so I'd rather turn this to vertex form. When I turn this to vertex form, I'm going to use completing the square to do so. So remember, with completing the square, you complete the square with the first two terms. And I guess I wanted that to be a different color. So we want to complete the square with the first two terms. All right, so what you're going to do is you're just going to put these in parentheses. Okay, the 17 will hang out on the outside. Okay, when completing the square, this value in front of the x squared needs to be 1. So what I'm going to go ahead and do is I'm going to factor out that 2. So I'm going to have y is greater than or equal to, I'm factoring out the 2 out of the first two terms. So I'm going to get 2x squared plus 6x plus box, this is where we're going to complete that square, plus 17. And if you add a box, you must subtract a box. The thing we need to be careful about on this is that our box, so I'll use my laser. Our box is technically being multiplied by 2. So we really have 2 times the box, so we have to keep it balanced. So we need to put a 2 here, 2 times the box. Just because there's that 2 that's going to be multiplied to that original box. All right, now remember, to complete the square, we use b divided by 2 squared. So our b value is 6. So we're going to get 6 divided by 2 squared. So that's going to give me a 3 squared, which is 9. So we're completing the square with 9. All right, so now you've made a perfect square trinomial. So now I have y is greater than or equal to 2. When this factors, we're going to get x plus 3 squared. Remember, it's going to be whatever the number was before you squared it, so positive 3, positive 3. And then we need to go ahead and do 2 times 9 is negative 18. So this is really 17 minus 18, which would give me a negative 1. So now this is in vertex form. So now this is really easy for me to graph because we can see all of our transformations. This is a vertical stretch by 2. This is opposite of what you think. This is left 3. Same as what you think, down 1. All right, so left 3, down 1. So left 3, down 1, that's going to be my vertex. Okay, so when I have a vertical stretch by 2, I'm going to take that 1, 3, 5 ratio, so over 1, up 1, over 1, up 3, over 1, up 5, and you're going to double that. So I'm going to go over 1, up 2, over 1, up 6, over 1, up 10. So over 1, up 2, over 1, up 6. 1, 2, 3, 4, 5, 6. All right, so now we need to ask ourselves, is this going to be dashed or solid? This one is solid because it is greater than or equal to, and since it's greater than, we're going to shade above. Or in this case, above is it's going to look like inside of the parabola. So we're going to go ahead and connect this with a solid line. Make sure it's rounded down here and not pointy. Okay, arrows on both sides. And shading above it means that on the inside, this is above. Imagine if you took this parabola and kind of like straightened it, made it into a straight line. What portion or what area of that parabola would be above your straight line? What would be below? So that would be above. And if you always wanted to test it, you could always test a point. I like testing 0. It's always going to be the easiest. So if we test point 0, we'd get 0 squared is 0, 0 times 2 is 0, 12 times 0 is 0, plus 17. So I'd get y is greater than or equal to 17. Well, the point's 0, 0, so 0 is greater than or equal to 17. That is definitely false. So where 0, 0 is should not be highlighted, and it is not highlighted. All right, and that's going to go ahead and conclude our notes for 4.11. Have a great day, everyone.